As we can see in question 2, Logan is investigating the effects of female adult giraffes. He records the height in metres of each of a sample of male adult giraffes and the height in metres of female adult giraffes. We have got a box plot here. As you can see, I have already gone in and I have labelled my minimum, my lower quartile, median, upper quartile and maximum, and have work out the mean from our box plot so we don't have a data point for that. Logan then makes the following 2 conclusions. Male giraffes are generally taller than female adult giraffes, and the heights of female adult giraffes are more consistent than the heights of male adult giraffes. For point 1, we would want to look at that median. Okay, so we can see that our median for a male giraffe is taller than the median for a female giraffe, so we can say that statement 1 is correct. As section 2 is looking at which is more consistent, we will work out the interquartile female giraffes. The male interquartile range, we've got our upper quartile, subtract our lower quartile, giving us an interquartile of 0.8. Our female interquartile range, we've got an upper quartile of 5.4, subtract our lower quartile of 4.8, giving us an interquartile range. As we said then, claim 1 we can say is correct, as the median for the male giraffes is greater, coming in at 5. And then our final 2 marks are for stating that claim 2 would be incorrect because that interquartile range for female giraffes is greater. For question 4, we are told Maya works in a factory that produces hammers. Today she is going to take a sample and check them for defects. This describes the population for Maya's sample. The population would be all of the hammers produced today. So identification numbers for each hammer, and is deciding between using quota sampling and systematic sampling. For each sampling method, assess whether or not it would be appropriate. For quota sampling, it would not be appropriate, as it is not random, it is a biased form. This would be the answer I would give. We get our first mark for stating that it is not appropriate, and our second mark. In this case, I've used the reason that it is not random, it's biased. Some other reasons we could have had though for that second mark. That you have got a sampling frame, the list of ID numbers. We are then asked about systematic sampling and whether or not that would be appropriate in this situation. Our first mark we would get is for saying as it is easy to take every nth item. So we have that reason of it is easy in this situation to take each nth item, that would get us our second mark. Again, we have that alternative for our second mark. For this question, we could also argue though that it's not appropriate. So we could have argued that yes it is, or our second option is mark for that, and then a mark for saying that there may be a fault at regular intervals. Our next question moves on, and we are told that this table shows some information in minutes of the time taken for 52 people to complete a 5 kilometre. We're given this incomplete frequency polygon, and our first part of this question is asking what number of people completed the race in under 24 minutes. We're looking at our table. 7 people completed it in under 20 minutes, and then another 25 completed it in 20. another 25. So we've got 32 people in total. We are then asked to complete our frequency polygon for the next part of this question. When we're drawing our frequency polygon, we plot the frequencies at the midpoints of our ranges for each class, or those different class intervals. First one has already been done for us. Our midpoint would be 18. We can see that that is where it is plotted on that first point. We would then have the midpoint of 22, 26, 30 and 34. We will then take our second one, which has been plotted at 25, so they have already plotted. Our third one is the one that we then need to plot. So we're looking at 26 on our x-axis and 12 on our y. Finding that point, we will place it there. We then, the next has also been plotted for us, so we then just have to complete this, filling it in using a ruler. When drawing this, we should always be using a ruler and pencil. I'm using a pen just so it shows up points with nice straight lines clearly drawn on. The next part of this question, then, we are asked to find the probability that this person in total, from our question, we were told that it is out of 52 people. So we know we've got a total of 52. 7 of these people took less than 20 minutes, meaning 20, leaving us with 45 people who took longer than 20 minutes to run the race. So we've got 45 over 52 will be our probability. And how the shape of this distribution of times can be used to compare the mean with the median time. Our first mark is for stating that there is a positive skew within this data. The mean will be greater than the median because of that positive skew. Our next question, we are told that the first decile for these results is 19 minutes and the 9th decile is 30 minutes. Work out an estimate for the first to the 9th decile into decile range. But if we know that so we'll calculate 30, subtract 19, giving us a range of 11 minutes. Again, just the 1 mark there. And then the final part of this question, find the class interval that contains the 65th percentile. To work out where the 65% of 52 is, using our decimal multiplier, will be where that percentile lives. Looking then back at our table, we know we have got 7 people. Our running total then, we've got 7 people in that first class. Adding on our 25 gives us 32. Adding on 12 will give us 44. We then have 50 and then 52. We can see then that our 33rd or 34th person, if we round it, is bigger than our 32nd. So our interval will be 24 to 28. Moving on to question 8, we are told a scientist is carrying out an experiment to test the effect of pairs. Our first part of this question is explaining what is meant by matched pairs in an experiment. It means that each person is similar characteristics. That is your first mark. This is so that you can control for other variables or factors, will be your second mark. The next part is one of the participants in the experiment. He takes 4 tests as part of the experiment and each test is given a different weighting. Table below shows the weighting and the score for each of these tests. We are then asked to calculate the first step is that we will need to multiply the weighting by the score for each situation. So we've got 3 multiplied by 43, adding on that extra column. So we've got 129, 4 lots of 25, 100, 5 lots of 19, from those together to work out sort of his overall score, giving us 516 when we have added them all together. The total of his different weightings then we can also add together, that gives us a total of 20. That gives us 25.8 as Jamal's mean score. Our first mark is for multiplying and summing these, our weightings and our scores. Second mark for dividing it by 20, because that is the total of that weightings column. And then final mark for getting the answer of 25.8. For question 10, we are told that a company produces bolts with a diameter of 16.4 millimeters. Tamika takes and the mean diameter of each sample is calculated. Her incomplete quality assurance report is shown below. So we are given that table and the associated graph. You then, because we are tasked with completing this, is to fill in that first missing value. So target sample standard deviation. We know that from our target line to our upper warning line, it should be a deviations. 1 standard deviation will be equal to 0.1. We can fill in that first point. We can then look at the rest of this table. We are told that our third sample falls, and we can see it on this graph as well, is above that upper warning. As this is outside of 2 standard deviations, we need to know that we then have to take that sample again immediately. So our point for sample number 3 has laid out a warning line. We have to take that sample again immediately. We then do that taking sample 4. We need to calculate the mean for sample 4, which will go in there. So calculating the mean of 4 data values. We've got 16.8 plus 16.3 plus 16.8 plus 16.7. That gives us a total of 66.6. To then use that to calculate the mean, we divide by how many samples we have. So dividing it by 4, giving us 16.65. As well as then plotting it onto that graph. So we have got 16.65 for sample 4. Again, And the reason for that is to reset or adjust the machine. So we've stopped the machine so that we can reset or adjust. Okay, so instead of saying stop the machine, we could have said reset the machine or adjust the machine as well. Our marks for this question then, we've got our first mark for a target fourth mark for correctly plotting that point onto our graph, and then our fifth mark for saying that we need to stop or reset or adjust the machine. For question 12, we are told that a bag contains red counters, blue counters and white counters only. So we know red has a proportion of P, blue has got a proportion of 3P and white is half of the counters. In this experiment then, one of the counters is selected from the bag and recorded in colour. She then puts the counter back into the bag. The counter is more than the probability then she selects exactly 2 blue counters. We are asked to use binomial distributions, meaning that we cannot just use a probability tree. We have to use those binomial distributions to determine whether she is correct, showing all of our workings. Our first step then is, but starting off, we know that the probability for all of these must equal 1. So we know that we've got P plus 3P plus a half must be equal to 1. Is 4P is equal to a half, meaning our value for P will be 1/8. If our value for P is 1/8, then 3P will be 3/8. We are then asked to use our binomial distributions to work out the probabilities to see whether or not it is more likely that exactly 1 red counter is picked than exactly 2 blue counters. Our probability we have got our binomial distribution, we have got 5 selections with a probability of success of choosing that red being 1/8. To work out the probability then of exactly one of those being a success, exactly one success of pulling out that red counter, we will use that 1 multiplied by our probability of success, which is 1/8, to the power of the number of successes, so to the power of 1, multiplied by our probability of failure, which if the power of the number of times that will occur. So if 1 time for our success, then we have got the other 4 selections must all be a failure. 5 is 1 will just give us 5. So 5 multiplied by 1/8 multiplied by 7/8 to the power of 4 of 0.366. So that will be our probability that she chooses exactly 1. I need to compare that though to the probability that exactly 2 blues are chosen. So exactly 2 blue. Again, same as last time, we will start by writing out our binomial distribution. We still have 5 selections, but our probability of success is now the probability of choosing, so will be 3/8. And this time we want our probability that this happens exactly twice, that we have 2. This means that we will now use our fact that 5 and we are choosing that blue twice, so we've got 2 successes. Our probability of succeeding is 3/8, that's our probability of It's 3/8 that we succeed. The rest of the time, so 5/8 must be a failure, and we must fail 3 times to choose that blue. 5 choose 2 then, using our calculator, or just knowing it, we know that that is equal to 10. So 10 times by 3 to the 3 over 8 squared, times by 5 over 8 in that selection is 0.343. As this is the case, we now have our probability of choosing exactly one red being 0.366, probability of exactly one blue is 0.343. Therefore, Salome and the reason being probability of exactly one red .366 is greater than the probability of exactly 2 blues. 3, 4, 3. Our marks then, we have got 1 mark all the way back at the beginning just for identifying that those 3 must all sum to 1. We then have a second mark for identifying P as an eighth and 2 marks. We then have 1 mark for using our binomial distribution for exact for getting those 2 values having used our binomial distributions. And then our 6th and final mark is for stating that Salome is correct, because we've used those 2 probabilities that we have worked out. For the final part of this question then, we are asked whether, by considering the conditions that make for this, we can say that as the events are independent and that there are a fixed number of trials, it will be appropriate. That would be a full 3-mark answer. We have stated that yes, it is appropriate, and we have given 2 marks as to why that would be appropriate. These are probably the answers I would have chosen. They are suitable for questions where a binomial distribution will be appropriate. We could also have said, though, that the probability of selecting a red is constant would also have been an appropriate reason, and that there are only 2 3 marks. Then we need to have stated that it is appropriate for 1 mark, and then 2 out of these 4 reasons. From a bag and records its colour. If the counter is red, she stops selecting. Otherwise, she puts the counter back in the bag and selects again. She repeats this process until a red counter is selected. She records the number of counters in this case then it would not be appropriate, as there is not a fixed number of trials. Okay, just the 1 mark for that, so we need to have the fact it's not appropriate due to the fact that there aren't a mixed number of trials. We don't know how many times she has taken that counter out of the bag. That is then the end of that set of questions.